This video is the first of the Logarithms modules, and in this video we're looking at logs A and B. To begin, let's look at the objectives of the Logarithms module. Firstly, to recognise and use exponential or index notation, and secondly, to use the exponent index laws to simplify expressions. Both of these things are covered briefly in the exponentials module of Transition Mathematics 1, so those students who have completed that module, this should be an extension or a revision of that. If you haven't completed Transition Maths 1 and you would like to get that module, please let me know. So thirdly, we're going to use the definition of logarithms to convert between exponential and logarithmic forms of expressions. We're going to evaluate expressions containing logarithms. We're going to simplify logarithmic expressions using identities and properties of logarithms. And we're going to solve logarithmic equations and then use logarithmic functions to solve application problems. So to begin, let's have a summary of exponent rules. Firstly, when x equals a to the n, we have to remember a is called the base and n is called the index or the exponent. A summary of our rules. Firstly, multiplying powers. When we have the same base, which you can see here, both a's, and we're multiplying, then we can add our indices. So this becomes a to the power of m plus n. So for example, a to the 4 times a to the 3 is a to the 4 plus 3, which is a to the 7. Next one, a bit more complicated because there's three different types of terms here. We've got a constant and two variables. So 2 times 3 firstly is 6. A squared times a to the negative 1, so 2 plus negative 1. Then the b, there's a 1 there, 1 plus 4. So it becomes 6a, 2 take 1 is 1, b, 1 plus 4 is 5. Okay, next, when we're dividing powers, so you see the division in the middle, again we have the same base. That must be the same base in order to use this rule. You can also write that as a fraction, and our rule here is that we subtract our indices. So for example, x to the 5 divided by x cubed is x to the 5 minus 3, which is x squared. Here, 5 divided by 15, you can't do it exactly. We don't want to write a decimal either. We prefer to write our answers with fraction form. So, best way to do this is to rewrite it as a fraction and then cancel. 5 into 5 is 1, 5 into 15 is 3. So you've got 1/3 m, 3 take negative 2 becomes 3 plus 2. So a third m5. That could be also rewritten as m to the 5 over 3. Okay? Anything to the power of 0 is 1. This one here, d to the power of 0 is 1. 1 plus 5 is 6. Here, all of this is to the power of 0, so the answer is just 1. When we have a negative exponent, a to the negative n, we always want to write with positive exponents, and the rule is you just move it to the bottom to become positive. If our negative exponent's on the bottom, it moves to the top to become positive. So example, d to the negative 7 becomes 1 over d to the 7. Here, if I've got a mix of positives and negatives, a to the negative 3 moves to the bottom to become positive. B to the 4 is already positive. C squared is positive, so it stays. D to the negative 5 needs to move to the top to become positive. Power of a power, we multiply our indices. So a to the mn. So for example, y squared all cubed, y to the 2 times 3 is y to the 6. A to the 6 all to the negative 2 becomes a to the 6 times negative 2, which is a to the negative 12. We need to write with a positive exponent, so it becomes 1 over a to the 12. Power of a product just extends from power of a power. You just have to remember everything in the bracket is to that power outside the bracket. Okay, so here m squared all to the 5, so it's m to the 2 times 5. n cubed all to the 5, so 3 times 5. So it's m to the 10, n to the 15. This one, the number is to that power as well. X, negative 4 times 3 is negative 12, n 2 times 3 is 6. 3 cubed is 27. The end of the 6 stays at the top, but that x to the 12 has to go to the bottom to stay positive. Power of a quotient, again, simply extending from the previous rules. A to the n over b to the n. This one, d to the 7 over e to the 7. Here, everything is to that power. So we've got a to the 2 times 3 is 6. B to the, there's a little 1 we don't write. 1 times 3 is 3. M, 5 times 3 is 15. N, 4 times 3 is 12. Fractional exponents. A to the power of 1 over n is exactly the same as the nth root of a. A to the power of m over n. Now because I can split that up to a to the m or to the 1 over n, and I can do that because of this rule here, then I can rewrite that as the nth root of a to the m. So x to the third, cubed root of x. X to the 3 over 4 is x cubed, the fourth root of that. So what do you need to do now? Well, you need to do some practice, and there are some exercises in the textbook. There's not a lot because this is a revision from Transition Mathematics 1. Again, if you'd like some more, then let me know and I can send you the exponentials module from Transition Maths 1.